Do you know what's like the secret web sauce to modern web apps? Authentication and authorization. Without these two, your online life would be one big mess. You wouldn't be able to log in or to create an account. The web would be filled with static web pages that you can't interact with because they can't remember who you are. That means no more ordering food online or watching hilarious cat videos in your Instagram feed. So here's the deal. In this video, we're taking the mystery out of authentication and authorization, and you will see how to use them in your project like a pro. So grab a cup of coffee and let's get started. The future of secure and user-friendly web apps is in your hands. Wait, but authorization and authentication, what's the difference? Authentication is the process of verifying your identity, just like showing your ID to the bouncer in the club. On the other hand, authorization is about determining what actions you can do once you're inside the club, like dancing on the stage or dancing in the sidelines. In web apps, authentication verifies users' credentials, like username and password, while authorization decides what features or routes the user has access to based on their roles and permissions. In short, authentication proves who you are and authorization what you can do. Okay, so now that we have that out of the way, let's start with something basic. Let's start with basic authentication. Basic authentication is the simplest form of authentication, and it works by sending a username and password as a base64 encoded string to the server. This string is sent in the headers of the request to the server in the following format: username, password. Basic authentication is integrated to modern browsers, so when a user tries to access a website protected by basic authentication, the server sends a special header back to the client. If the browser detects such a header, it will render a authentication pop-up, and it will do so until it receives a 200 code from the server. The key takeaway here is that the server doesn't save anything about the user between requests, so the same credentials need to be sent over and over again. Browsers mitigate that because they store the credentials in their cache until they are restarted. But if we use a API client such as Postman, we see that we need to send the credentials every time. But don't take my word for it, let's write some code. So we have a very simple Node.js server here running on Express.js. I'm using the Express Basic Auth middleware that comes from the npm package repository, and the middleware is initiated here. The middleware has a user's object that stores the username and passwords of the users that can access the website protected by basic authentication. Here it's written in plain text, but you can provide a authorize function that can, if needed, fetch the users from a database. The challenge here tells to the server that it needs to send the www authenticate basic headers if the authentication is not correct. And the root endpoint that sends a cats.html file, which contains our cats memes, is protected by the basic authentication that is saved in the auth variable here. In this case, authentication is equal authorization, because virtually there's no difference between providing your identity, username and password, and actually making the request to a specific route. If I run the server by typing npm dev basic auth and go to my browser, I will get a authentication window. If I provide the password and the username as indicated here, the website will let me in and will show us our cat memes. So basic authentication is a very straightforward way to protect your server, and it's usually used to put a website behind a password or really simply protect an API. Session-based authentication is a popular method for handling user authentication and authorization. Session-based authentication uses secure cookies, is lightweight, and is generally the best way to handle user authentication. Sessions, for instance, make it possible to stream music across different devices, as done in Spotify. Unlike basic authentication that require user credentials at every request, in session-based authentication, the user only provides them once during the login or sign-up process, and then can do any subsequent request with something called a session ID. Here's how it works. When the user logs in, the server creates a session identifier linked to the user. With each subsequent request, the user sends back that session identifier to the server, so the server knows it's a returning user. I will show you how to implement session authentication and authorization using two popular packages: Express Session and Cookie Session. With Express Session, the session data is stored on the server, and only the session ID is sent to the client that is stored in the browser's cookies. In that case, most of the time sessions are stored in a database, in-memory database, such as Redis. This helps with scalability and provides a very granular control over how we manage those sessions. In contrast, with Cookie Session, the whole session is stored on the client. So the client stores the session ID and the session data. This is only useful when your application is very small and typically is running on one server. But enough of the talk, let's see the code in action. So here we have a small project using Express Session. I'm using TypeScript here, so I need to extend the session data user property. So basically, when we have access to the session, we can do request session and user. User is going to be appearing here because we have declared it here. So it extends the normal user data that comes from Express, and this is a way to do it in TypeScript. And you see that I can have access to that username. So that's just a TypeScript thing, so you know. The rest is pretty explanatory. We initialize an Express server at port 3333. This is our database of users, similar to what we have in basic authentication. So username Salim and password supercat123. We configure Express.js to be able to accept a body and parse it accordingly, whether it's an application JSON or a URL encoded form. This is where the session is initialized. So the secret key to sign the session is here, keyboard cat, and we declare it as a cookie, and we say that we don't want to use secure cookies because here I'll be on localhost. I won't use HTTPS, I won't use TLS. And here's our auth middleware. What it does is that if it doesn't detect the user object in the session, it's going to throw a 401 error, which is very common to throw a unauthorized error. And if everything is okay, it just calls next, so the next middleware in the chain. And this is our root endpoint. It is protected like in basic authentication by the auth middleware. And we have a sign-in route here because we use session-based authentication. So in session-based authentication, as opposed to basic authentication, you provide the password and username once, and then you get a session ID back, so you can identify yourself to the server by this session ID. So the logic here is that it receives a username and a password that comes from the body of the request, and for that we're going to use Postman, so we don't have to create cumbersome UIs, and it's just going to be easier to test it out. And basically, if we don't find a username, we will return a 403 code credentials incorrect, and if the password is not correct, so this is how we compare it, we also return a 403 send credentials incorrect. And we don't want to return any more data because we don't want to indicate to the possible attacker whether a user exists on our platform or whether the password was just incorrect for an existing user. That's just like a common sense when you're building that kind of logic. And then if everything is going well, we are assigning the user object to the session, and we are assigning the username, the one that was provided. So very simple logic, of course, a bit far away from the reality. If you want to have a real logic that uses real authentication with sessions, you can refer to my course that is available on codewithvlad.com. And if everything goes okay, we are sending a status 200 with a just OK string. By the way, all that code will be available in the description below of that video, so feel free to download it and play around with it. You are welcome. So we are going to start the server here and navigate to our Postman, where we can test the endpoints. So we have the sign-in endpoint and the root endpoint. And the sign-in endpoint is a post request. So here it goes. We have a post request here that needs to accept a body. We will provide username Salem and password supercat123. Once that is done, actually let me reduce the size a bit, we receive a code 200 and a status OK. Now the nice thing with Postman is that it automatically saves the cookies and anything that the server sends. So if we check here the cookies, we see that a connect SID has been saved in the cookies of the Postman. So we can delete that or just leave it here to test various scenarios. We can go into our root endpoint and send a request. And if we send the request, you see that we have a code 200 and we have the website here, it appears here. However, if we go in the cookies and delete the connect SID, and this is the session ID, by the way, that is sent by the backend, and the backend has created the session data, the object with the user and the username in the server's memory. Usually you would use something like Redis, but here for the example, it's just saved in the server's memory. So if we delete the connect SID and we do the request again, we will get a 401 unauthorized error, which makes sense. So that is the example with session based authentication using express session. Now let's check the example with the cookie session. So here's the next example with cookie session. It's very similar to express session, except that we're using the cookie session middleware here that we initialized here. And we just provide a key that is similar to the key used in express session. And that key is going to be useful to sign the session. And the rest of the logic is very similar. It's pretty much the same logic. But the main difference is that how the cookie is going to be saved, and we're going to see that in a moment. So I'm going to start the cookie session project here. I'm going to go back to my Postman and try to log in again. So I do the request here, and let's actually go and check the headers. Here are the headers, and we see that the server sends us two set cookies header, one with the session data and one with the session ID. And the session data is in base64. Actually, if we go ahead and copy that and paste it in a base64 decoder, we see that if we decode that string, we get the object in a stringified form. Let's come back to our Postman and actually check that the cookies have correctly been saved in the cookies of the Postman. So we see here that we have a session and the session ID. And that's the main difference between cookie session middleware and express session middleware. In production, in most of the projects that grow with more than one server, you would want to use the first one, the express cookie. But if you have a very small project, like almost a toy project and with one server only, that is fine as well. That is actually very similar to JWTs, where the whole kind of data of the user is stored on the client. And we're going to see JWT in a moment, but for now, let's do the request here to the root endpoints to see that everything is working. And we got a 200 code here. By the way, if we delete one of those sessions, either the session data or the session ID, the request won't work because the request will basically fail. Here we go. Finally, let's talk about JWT-based authentication and authorization. JWT or JSON Web Tokens is a relatively modern way of granting users access to modern web applications. I know it's used a lot, I have seen it used in project, I even have a video on the subject on my channel, but please don't use JWT for user authentication and authorization. Use session-based authentication, and here's why. Remember, authentication means providing username and password. Once the user has signed in using the JWT-based authentication, the server generates an access token and sends it back to the client in the response body. This is the authentication part. This access token is typically short-lived, let's say 15 minutes. The client then sends that token back to the server with each subsequent request, allowing the server to verify the authenticity of that token and authorize the request. This is the authorization part. The main issue with JWTs is that once they are generated, they can't be invalidated. As long as they are not expired, they are valid. That means that the user can hold on to an old access token and still have access to data that he's not supposed to have access to. Let's say you delete the user. If the user still has the access token, he can still access the user information. This is because the idea behind JWTs is that they are stateless. They are self-contained. Everything is inside them. You don't need anything else. You don't need to have a call to a database to validate anything. Except that if you are using JWTs in your normal CRUD applications, meaning create, read, update, delete application, you will have to do calls to the database. You would want to implement true logout functionality. You would want to make calls to the database to update user last time of activity, for instance. So you should not use JWTs for user authentication and authorization because of those reasons. They can't be invalidated, and if you try to overcome that, you will implement something that resembles vaguely a session but will do a worse job. They are heavier and have a bigger payload than sessions. They are not more secure because you might actually want to store the access token in your local storage and change the UI based on the content of the access token. As opposed to sessions that would be stored into the HTTP-only cookies, that means cookies that are not accessible by your browser's JavaScript. The idea behind JWTs is that they are self-contained and that you don't need to have a call to the database to verify the information, except that in your application you probably will have to do that anyway. They are really more complex than traditional session-based authentication, and I haven't even started talking about refresh token or authorization servers. It's a complex topic. However, what's the use case? Why would you use JWTs at all? Why do they exist? Here's why. Let's say you are Adobe, the company, and you want to grant your users the ability to download another Adobe product. Instead of having to come up with a very cumbersome way of logging the user in other products, you can generate a JWT with your main account, and that JWT will give you access to a 15 minutes download window for that Adobe product. And here's another use case. Let's say you are Google and you want to give access to other companies to the Gmail of your users, of course, if they have allowed it. You can do that easily with JWTs, where Google would generate an access token, giving access to a specific information of that specific user for a certain amount of time. And the application or the UI that makes the request to the Google service with that access token could actually get that information during that short period of time. However, when it comes to user authentication and authorization with sign-in and sign-on functionality, JWTs are not a great option. Again, this is because mainly JWTs are stateless and can't be invalidated. You can't log out a user from all the platforms, and you have less control of how the user are actually using your platform. But regardless, I will show you how to implement JWT authentication and authorization in your application right now. We have here a very similar project to the previous ones, except that we are using JWT that comes from JSON Web Token library. So very similarly, we are creating an Express.js server on port 3333, and we just provide a JWT secret here, similar to the secret that we are using in sessions. This secret is going to be useful to sign the token. And then we have our database here, and similar to the previous part, we have the middlewares to parse the body. Next, we have the auth middleware. The auth middleware is a bit different. So the auth middleware will receive the token, the access token. So the token is usually passed in the headers as a bearer token. So that means bearer space your access token. So we are getting the authorization header here. That means that you haven't provided anything regarding authorization. So we throw 401 code. And if the authorization header is present, we isolate the token. So the format is in a string bearer space access token. So we take the token and split by this empty space. Then we verify the token with the secret. So we make sure that we are the ones, this server has signed the token. And if it is correct, we are going to just save it here for further use. Here we're not going to use it, but it's a good way to transmit your data between middlewares. In that case, we are going to save it in a locals variable, the user object specifically, that comes from the decoded JWT, and then we pass to the next. Obviously, if something is wrong on that level, we throw a 401. That means that something didn't work correctly. And actually, just for consistency, let's also use the same string here. Here we go, and we have the root endpoint protected by the auth middleware, and finally the sign-in endpoint. The sign-in endpoint is almost similar to the previous sign-in endpoint from the sessions, except for this part. Basically, here is if everything is correct, if the username and the password provided is correct, we create a JWT, so we create a token, we sign it with the secret that is provided above, and we create a object with the username, and we provide an expiration date, which is 1 hour. So this access token specifically will be available, will be expired after 1 hour. And if everything is correct, we are sending that access token as a application JSON response here in the body. Let's go to Postman to see it in action. So here's our Postman, and we have the same routes pretty much. We can do a post request to the sign-in endpoint. Here we go. And if we check the body here, we see that the body received is the access token. So the access token, we can view it and see what's inside. So you see here that we have username, Salem, and an expiration date, which happens in 1 hour. So the key thing here, and that's a big difference between JWT and sessions, is that nothing in the case of JWT is saved automatically. So the front end needs to actually go ahead and save it manually in its memory. So if I request the root endpoint now, I'm going to get a 401 error because I haven't provided any authorization header. So what we need to do is to copy that access token, and if you are building a front end using JWT, you will have to do that programmatically, of course. So we're copying that access token, we're going to the headers here, we provide the authorization header, and you see that here I already have something, and basically the format is bearer space and the access token. Once that access token has been provided, we can do the request, and now the authorization works. And there you have it, folks, a crash course on authentication and authorization. If you found this video helpful, give it a like and hit the subscribe button. That way you won't miss any future videos where we explore the world of web development together. Now go forth and authenticate with confidence.